All right, so pre-calculus, chapter 3.4, Apex version. So in 3.3, we talked a little bit about multiplicity. Now we're going to define what multiplicity is. So the multiplicity of the root is the number of times that this factor, okay, is a factor of the function. Okay? If the root has even multiplicity, it means the graph will touch the x-axis and will bounce off of it. If it has odd multiplicity, okay, then it means it bends as it crosses the x-axis. So we have three different multiplicities that we're going to deal with. The first one is a multiplicity of 1. This is the one that you guys are used to looking at, where you see a graph and it crosses. Okay? So it doesn't bend, it just crosses right through. So that's a multiplicity of 1. Okay? Right here, you can see that this one touches at a spot and bounces off of that axis. That is a multiplicity of 2. A multiplicity of 3 is like your cubic function, so your x to the third functions, okay, where it comes up here and it bends and then continues on. Okay, so those are the three multiplicities that you guys need to focus on. And the reason you need to focus on them is because sometimes when you solve functions and you find the x values, sometimes you will find an x value that occurs 2 or 3 times. That means it's a multiplicity. Okay, it doesn't mean that it's not a factor or an x or a root. It just means that it occurs multiple times. Okay, so let's go ahead and take a look at a couple of these. So this one right here says, graph this on your calculator. What I'm going to do first, though, is I'm going to go on ahead and factor this by grouping so that you can see. So here, I can take out an x squared, and I'm left with x minus 9. And I can take out a 27, and I'm left with x minus 1. So here I get x squared plus 27. Okay, and oh, what did I do there? Let's see, this one might not work this way. So this one's not going to work this way. Okay, well, I thought this one would, but the next one will definitely work. So I'll show you the next one. This one I would have to just factor. I would just have to divide in order to solve it. And we'll go ahead and do that here in a minute too. But let's go ahead and graph it so we can see what the roots might look like. So it's an x to the third. So we know it's got to have 3 roots, right? Okay, so now I'm in my y equals, and I'm just going to graph it. So x to the third minus 9x squared plus 27x minus 27, and I'm graphing it. Okay, so right there. Okay, well, I have to have 3 roots, but it looks like it only crosses 1 time. So I'm going to go into my table, and I'm going to look. Mine's kind of set a little bit weird. And it looks like it crossed around 3. So I'm going to go up until, oh, there we go. So right at 3. So my x is 3 and my y is 0. So I'm going to go on ahead then and do some synthetic division. Okay. I'm going to divide this thing by 3. So I have 1, -9, 27, and -27. Okay, so let's take a look. 3 times 1 is 3. It's -6. 3 times -6 is -18. 27 minus 18 is 9. 3 times 9 is 27, and I get 0. So we know that 3 is a root. Okay, well, now we're left with x squared minus 6x plus 9. If I factor this, I get x minus 3 and x minus 3. So if I set those equal to 0, right, then I get x equals 3. So I get 3 times, which means it's a multiplicity of 3. So I still have 3 roots. It's just the same number that has a multiplicity of 3. It occurs 3 times. Okay, so don't think that just because you get 3 and you can't find anything else, or your graph looks like it only crosses in one place, there's only 1 root, even though we know there has to be 3. Okay, this multiplicity changes the way the roots work. Okay, so let's go ahead and let's take a look at this next one. So I was going to try the same thing here. I don't know. Let's see, 200 divided by 30. Nope, so that doesn't work. Okay, so let's go ahead and just graph this one then. So we're going to have negative, make sure you use the negative sign and not the minus, 2x to the third minus 12x squared plus 30x plus 200. So looking at this graph, we can see that it bounces off here and it goes through there. So it looks like this is going to be a multiplicity of 2 because it bounces off, and this is going to be a multiplicity of 1. So it looks like our answers for this is x is going to equal 1, 2, 3, 4, 5, negative 5 with a multiplicity of 2, and x equals 4 with a multiplicity of 1. All right, so now I'm going to go on ahead and just solve this. It doesn't really matter. I'm going to start with negative 5. So I'm going to take negative 5, so that's negative 2, negative 12, 30, and 200. Bring that negative 2 down. I get 10. I get negative 2. I get 10. I get 40, and negative 5 times 40 is negative 200. So now here, I have negative 2x squared minus 2x plus 40. If I take a negative 2 out, then I'm left with x squared plus x plus 20. And so this is negligible, right? Because in the end, if I said negative 2 equal to 0, it never happens. So now this factors to x plus 5 and x minus 4. And oops, I just threw my pen. So here, I made a mistake when I took that negative 2 out. That should have been a negative 20. Okay. All right. So now that is x equals negative 5 and x equals positive 4. Okay, which gave me those answers. Okay. So you want to keep track of that because that is very important. Okay. All right. The next thing that we're going to look at is upper and lower bounds. So we've already looked at what are the possible zeros of a function. So here, if I'm looking at the possible zeros, I would take this number and any factors of it and divide it by any factors of this number. So 1, 2, 3, and 6. Okay, so here I could have plus or minus 1/2, plus or minus 2, plus or minus 1/3, plus or minus 1, plus or minus 1/6. Okay, there's a lot of options here, but we want to narrow these down a little bit. Okay, so we're going to start looking at upper and lower bounds. Okay, so if I have a polynomial with a positive leading coefficient and I divide by some value, x minus c. Okay, so that's going to be my factor. So that would be like x minus 7. Okay, then I know that if my c value is positive, okay, so if it is x equals 7, that's a positive value, and each number in the solution is either positive or 0, then c is an upper bound. In other words, there's not going to be any zeros past that. So if I plugged in x equals, I don't know, we'll say 3 here, okay, and every number in the solution was positive or 0, there would not be any solutions past that positive 3. Okay, so I know that it wouldn't cross the x-axis anywhere in this direction. The same thing goes for negative. So if c is less than 0, okay, so c is negative 3 here, okay, and my solutions are alternating positive and negative, and 0 can count as a positive or a negative, then I know that there's no solutions past that negative 3. So that just means that from here, I could narrow these numbers down. I might not have to try all of them. Okay. All right, so let's take a look. So this says determine if x equals 1 and x equals negative 1 are zeros, upper bound, or lower bounds. Okay, so if it's a 0, I'm going to get 0 for a remainder. Otherwise, we will see if it's an upper or lower bound. It could be neither, okay, but we're going to check. All right, so the first thing, x equals 1. I'm going to divide by 1. So I have 6, negative 4, 3, and negative 2. Okay, so x equals 1. Let's see what happens here. 1 times 6 is 6. That's 2. 1 times 2 is 2. That's 5. 1 times 5 is 5. And so that's 3. So every single one of these numbers was positive, and this was positive. That means that x equals 1 is an upper bound. So in my possible zeros here, when I have 2 over 1, that is not going to be a possible answer. Okay, so I could mark that one off. Now, 2 over 2, not going to be a possible answer. Okay, because 1 is, oh, I guess that could be a possible answer because that would be 1. Okay, so it could be 1. 2 over 3 could be an answer. 2 over 6 could be an answer. Okay, but anything past 1 is not going to be an answer. So I don't have to try any of those values. Right? This is not a 0 because the remainder was not 0. So now let's try -1, and I'm just going to go back to this original function. 6, -4, 3, -2. So I have 6. -1 times 6 is -6. That's -10. That's +10. That's 13. -13. That's -15. So here it went positive, negative, positive, negative. This was less than 1. So x equals -1 is not a 0, but it is a lower bound. So anything, so I know then that when I graph this function and I have a 1 and a -1, all of my zeros are going to be in here. So this function is going to cross or touch the x-axis somewhere between -1 and 1, nowhere else. All right, so let's take a look at concavity. Okay, and then we're going to look at some absolute maxima and minima also. All right, so concave up looks like this, and it bends like a smile. Concave down looks like this, and it bends like a frown. Okay. You also have a point where the concavity changes from up to down or from down to up, and that's called an inflection point. An inflection point. So when we graph functions, okay, we'll have a function that sometimes looks like this. Okay. These ends right here are called absolute maximum. And this one is the absolute minimum. But you can see that we have another minimum and another maximum right here. These two are called the relative maxima and minima. A relative maxima and minima. Okay. And I'm going to show you guys how to find that on your calculator. You've already done it once before, but we're going to go on ahead and see what it is. So we're just going to use this function that we have from the other page. Okay. So we've already got it graphed. Okay. Now what you're going to do, let's see, let's find a good spot for this thing, okay, is you're going to hit second trace. So you're going to go to calculate. We're going to go to minimum. Okay, hit enter. Then I'm going to scroll till I'm a little bit on the left of this minimum. So I have to get all the way over until I'm a little bit past the -5. And you can see my little black thing blinking right there. Okay, it doesn't matter if I'm here or here. Okay, I just want to be a little bit to the left of that minimum. Okay, and you see it put an arrow there. It's kind of hard to tell. Let's see, I'm going to come this way just a little bit so that maybe we can see the arrow a little bit more. So I came to the right of it, and you see now that arrow. So now it's saying, hey, there's a minimum between these two arrows. Okay, and you can see here it says, do you want me to guess? Okay, you're going to hit enter, and it's going to guess for you. I hope I hit enter. I wasn't looking at it. Yep. So now my minimum is at x equals -5, 0. Okay, so that's my relative minima. Okay, or minimum. Plural is minima or maxima. Okay, at -5, 0. Okay, so you do need to know how to find that. Okay, so make sure that you write it down. I'll also put some calculator tips in Google Classroom for you guys so that you can see them, and it has that on it. All right, so that is it for 3.4. Make sure that you know it, memorize it, learn it well. Have a great day.